So you may have noticed from the last few videos that evaluating derivatives using the limit definition can be pretty tedious sometimes. So you might be wondering, well, if I have a function and I need to find the derivative at a few different points, do I have to go through that process each and every time? And the answer is no. And there's a couple things you could do about that, and we'll talk about one way in this video. So we could evaluate the derivative as a function instead of at a specific point. And this is example one of doing that. So we want to use the limit definition of the derivative to find f prime of x, where f of x is 2x squared minus 3x plus 1. And then we want to use our result to evaluate f prime of 0, f prime to negative 2, f prime to 5, and f prime of 11. So what we're going to do is start by saying, well, in general, the derivative of a function f of x is the limit as h goes to 0 of f of x plus h minus f of x all divided by h. So exactly the same thing we did when we evaluated the derivative at a point, but instead of talking about the specific point x equals c, we're just leaving everything as x. So our result from this limit is just going to be a function of x. So first we want to simplify what is f of x plus h. Well, f of x plus h is 2 times the quantity x plus h squared minus 3 times the quantity x plus h and then plus 1. So we just substitute x plus h in for x into our f of x here. And then we are going to expand this, FOIL this. X plus h quantity squared is going to give us x squared plus 2xh plus h squared. And then here, distribute the minus 3. So we get minus 3x minus 3h, and then we still have the plus 1. Now we want to distribute the 2, so we get 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. All right, so that's kind of a mess. And then f of x is still just 2x squared minus 3x plus 1. All right, so now bring those both to the next page. And then here is our derivative expression, also from the previous page. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all divided by h. Well, we know what both of these things in the numerator are, so let's take these expressions up here and put them into the numerator. So we end up with the limit as h goes to 0 of this whole thing right here. That's our f of x plus h, and then minus f of x here. So you might be looking at this saying, well, hey, that's not quite right, because we want to make sure that we have parentheses around this here. Okay, so this 2x squared minus 3x plus 1, we have to have parentheses around that, because this whole thing is f of x, and we're subtracting all of f of x from the expression f of x plus h. So we need to make sure that we have parentheses around this here because we're subtracting the entire thing. If we forget the parentheses, then everything's going to be wrong and it's not going to work out, and we'll be stuck and not sure what happened, and it'll be hard to track down. So we do want to make sure that we want to have these parentheses here. All right, so then let's go ahead and simplify. So all this stuff stays the same. This whole f of x plus h expression stays the same, and we're just going to distribute the minus sign into here. So we get minus 2x squared plus 3x minus 1 after we distribute the negative sign into the parentheses. All right, now let's go ahead and start simplifying. So in the numerator, 2x squared minus 2x squared, so those cancel. 4xh combines with nothing, so we still have 4xh there. Plus 2h squared also combines with nothing, so we have a plus 2h squared there. Minus 3x plus 3x, those cancel. Minus 3h combines with nothing, so we still have a minus 3h. And then plus 1 minus 1, those cancel. So in the numerator, we just have 4xh plus 2h squared minus 3h, and that's all divided by h. And we're still taking the limit of everything as h goes to 0. So now from the numerator, we want to factor out an h. Each term has an h in it, so we want to pull that h out. And we end up with h times the quantity, 4x plus 2h minus 3. All that's divided by h, and we're still taking the limit as h goes to 0. Now, what's great about this is the h on the top cancels with the h on the bottom, and we just end up with the limit as h goes to 0 of 4x plus 2h minus 3. Now we can do direct evaluation. Since we're taking the limit as h goes to 0, we'll just directly substitute 0 in for h. And we end up with 4x plus 2 times 0 minus 3. 2 times 0 is, of course, just 0. So we get 4x minus 3. And that's our derivative as a function. So f prime of x as a function of x is just 4x minus 3. Now we need to find these four specific derivatives here, and we don't have to go through the limit process anymore. We can just take these values of x, 0, negative 2, 5, and 11, and plug them into our derivative function here. So f prime to 0, we plug 0 in for x, we get 4 times 0 minus 3, which simplifies to negative 3. So f prime to 0 is negative 3. And f prime to negative 2 is 4 times negative 2 minus 3, which is negative 8 minus 3, which is negative 11. And f prime to 5 is 4 times 5 minus 3, which is 20 minus 3, which is 17. And finally, f prime of 11 is 4 times 11 minus 3, which is 44 minus 3, which is 41. So we see that if we have to find the derivative at several different points, it's easier to find it as a function first, a function of x here, and then just plug in the different values of x one at a time.